their GPUs to create the largest distributed computer ever. 1 million gamers united to counterstrike the COVID-19 coronavirus. The result was 2.8 exaflops, 5 times the processing power of the world's largest supercomputer to simulate the virus. Folding at Home was able to simulate 100 milliseconds, a tenth of a second in the life of the coronavirus, and capture the moment it opens its mouth to infect a human cell. Scientists believe this is also its moment of weakness. We love computer graphics and have advanced it incredibly in the time of NVIDIA. As the technology advanced, the expressiveness of the medium has made graphics an invaluable tool to help us understand our world, create and explore new worlds, tell stories that inspire us. From science to industry to the arts, computer graphics has made a profound impact on the world, and for that, we are privileged to have contributed. We're going to talk about gaming and the infinite ways that gaming is expanding. GeForce PC gaming is large and thriving. Its open and rapidly advancing technology, combined with the amazing creativity of the community, makes magic. Anyone could be a broadcaster now. Add a GeForce and you have a personal broadcast station. Pros stream their practices. Experts stream tips and tricks. Friends stream to friends just to hang out. There are over 20 million streamers. Games have become a new art medium. In Minecraft, gamers can build their work of art. Machinima artists create cinematics made from game assets. Tens of millions are using games to express their creativity. Inside a computer simulation, any sport can become esport. Virtual NASCAR and F1 are already attracting top racers. Like sports, esports captures the thrill of victory and the agony of defeat. And the human night, the #1 and #2 most played games of Reaction time is a combination of the gamer and the machine. Let me explain. This is Valorant. In this example, the opponent is traveling at 1500 pixels per second, and it's visible in this opening for only 180 milliseconds. A typical gamer has a reaction time of 150 milliseconds from photon to action. You can only hit this opponent if your PC adds less than 30 milliseconds. Most gamers have latencies far greater than 30 milliseconds, many up to 100 milliseconds. Today, we're announcing a new esports technology called NVIDIA Reflex. NVIDIA Reflex optimizes the rendering pipeline across CPU and GPU to reduce latency by up to 50%. In September, we're releasing Reflex with our game-ready driver. Over 100 million GeForce gamers will instantly become more competitive. Valorant, Fortnite, Apex Legends, Call of Duty Warzone, and Destiny 2 will be the first to integrate Reflex technology. 60 Hz, 144 Hz, and 360 Hz display. You can see immediately how 360 Hz display will help you target and track an opponent.
Guys are getting better.
NVIDIA RTX is a full-stack invention. RTX starts with a brand new GPU architecture, but it is so much more. It includes new engine tech and a bunch of new rendering algorithms. RTX is a home run. All major 3D APIs have been extended for RTX. RTX is supported by all major 3D tools. RTX tech is incorporated the programmable shader that we first introduced over 15 years ago, RT Core to accelerate the ray triangle and ray bounding box intersections, an AI processing pipeline called Tensor Core. Tensor Core accelerates linear algebra that is used for deep neural network processing, the foundation of modern AI. AI is the most powerful technology force of our time. Computers that learn from data and write software that no humans can. The advances are nothing short of breathtaking. NVIDIA is doing groundbreaking work in this area. You might have seen our work in self-driving cars and robotics. Computer graphics and gaming will also be revolutionized by deep learning. Let me show you some recent works and the art of the possible. The first video is a generative adversarial network. that has learned to synthesize virtual characters of any artistic genre, including photorealistic. Second is a neural network that animates a 3D face directly from voice.
You require more Vespine gas. It's dangerous to go alone. Take this.
The AI character can speak in any language, be any gender, and even rap and sing. Third is a character locomotion of infinite number of positions. Imagine negotiating arbitrary paths and obstacles. The fourth is reconstructing 3D from video. Imagine the possibilities. Record video, interact in 3D. This one is a deep learning model that learned the physics behavior of cloth animation. Finally, this deep learning model of ray tracing can predict colors of missing pixels, so that fewer rays need to be cast and fewer pixels need to be fully rendered. We can achieve orders of magnitude speedups. AI is certain to play a giant role in the future of computer graphics and gaming. The powerful tensor cores in RTX a lot more computation per pixel than rasterization. So the solution is to ray trace fewer pixels and use AI on tensor cores to up-res to super-res to a higher resolution and boost frame rate. DLSS took nearly 2 years of intensive research. We built a supercomputer to train the network. The DLSS model is trained on extremely high quality, 16K, offline rendered images of many kinds of content. Once trained, the model is downloaded into your driver. At runtime, DLSS 2.0 takes in low resolution, aliased image and motion vector of the current frame, and the high resolution previous frame to generate the latest game by Kojima-san. DLSS is sharper than native 4K and created detail from AI that native rendering didn't even show, and the frame rate is higher. Reviewers have loved DLSS 2.0. They say its quality beats out native rendering and runs even faster. You can play at 4K without a performance hit. Tensor Core effectively gives RTX a 2x performance boost. Let's look at one frame trace of a game to see the processors of RTX in action. Adding ray tracing to games dramatically increases the computation workload. Using shaders to do ray traversal and object intersection reduces the frame rate. We added the RT Core, which reduces shader workload by 60%. RT Core offloads the shaders by doing the ray triangle and ray bounding box intersection calculations. Using the same methodology as Microsoft Xbox, the RT Core is effectively a 34 teraflop shader, and Turing has an equivalent of 45 teraflops while ray tracing. Even then, 20 milliseconds is only 50 frames per second, and still a step back in performance relative to previous generations. This is where the Tensor Core and DLSS come in. Rendering to a lower resolution, then using AI and super fast Tensor Core to effectively double frame rate. Now you can get ray tracing, get high resolution, and high frame rate at the same time. Turing was our first generation RTX GPU, combining ray tracing, programmable shading, and AI. The flagship Turing had a ton of processing power, 11 shader teraflops, 34 RT teraflops, and 89 tensor teraflops. Let me show you our new RTX GPU. Ampere is a giant leap in performance. Ampere does 2 shader calculations per clock versus 1 on Turing, 30 shader teraflops compared to 11. Ampere doubles ray triangle intersection throughput. Ampere's RT Core delivers 58 RT teraflops compared to Turing's 34. And Ampere's new Tensor Core automatically identifies and removes less important DNA weights. And the new Tensor Core hardware processes the sparse network at twice the rate of Turing, 238 tensor flops compared to 89. Ladies and gentlemen, NVIDIA's new Ampere GPU, our second generation RTX, 28 billion transistors built on Samsung 8N NVIDIA custom process. All 3 processors double rates over Turing, a triple double. It connects to Micron's new G6X, the fastest memories ever made. 2 times the performance and energy efficiency of Turing. At NVIDIA, we use every engineering and real application performance highlights Ampere's new RT Core. The more ray tracing is done, the greater the Ampere speedup. Ampere RT Core doubles ray intersection processing. Its ray tracing is processed concurrently with shading. And Ampere can render cinematic images with motion blur, 8 times realistic real-time graphics. It was running on our highest-end Turing Quadro RTX 8000. Turing was doing 720p, 25 frames per second. Gentlemen, enjoy marbles at night. Marbles is entirely path traced. No rasterization, all real time. There are hundreds of area lights, including spherical area lights. There's no pre-baking, everything is dynamic. The depth of field is film quality and beautiful. Everything is dynamic. Diffuse GI, all dynamic. There are hundreds of rigid bodies, 80 million triangles. Materials are physically accurate, physics simulation and volumetric rendering in real time. DLSS 2.0 is doing the super resolution and AI denoising. Marbles on Turing runs at 720p, 25 frames per second. Marbles on Ampere runs at 1440p, 30 frames per second. More files from disk and decompress the game image. This is fine when the storage system was slow, 50 to 100 megabytes per second. Now with Gen 4 PCI Express and solid-state drives, PCs can transfer data at 7 gigabytes per second, 100 times faster. CPU copying data to memory and decompressing game images. However, decompressing from 7 gigabytes per second SSDs on PCIe Gen 4 takes over 20 CPU cores. Today, we're announcing NVIDIA RTX I/O with 3 new advances. New I/O APIs for fast loading and streaming directly from SSD to GPU memory. GPU lossless decompression. And collaboration with Microsoft on direct storage for Windows that streamlines the transfer of data from storage to GPU memory. Now let me tell you about some of the other exciting technologies inside. Turing used G6, the fastest memories at that time. The industry thought that was the limit. For Ampere, we had to push through that limit. Working with Micron, we designed the world's first memories with PAM4 signaling, pulse amplitude modulation, with 4 voltage levels that encode 2 bits of data each, 0001, 1011. Each voltage step is the outside, flowing through the GPU and pushing hot air straight out the chassis. Engineers architect a super dense PCB design that is 50% smaller than previous, pushes the heated air out through the graphics card brackets. A backside pull-through fan passes cool air over the fins of the heat pipe and directs the hot air to the top and back of the chassis to be exhausted. Let's see how the 3080 stacks up to previous generation architectures on the latest graphics-intensive games. 3080 is faster than 2080 Ti. 3080 is twice the performance of 2080 at the same price. Ampere is the biggest generational leap. Powered by Ampere, our second generation RTX GPU architecture. Incredible amounts of processing in the shader, RT ray tracing core, and tensor core for processing AI. 10 gigabytes of G6X, twice the processing power of 2080. And at the same price, starting at $699. Available September 17th. 970, 1070, 2070 were all hugely popular. You're gonna love the new RTX 3070. Faster than the 2080 Ti, the Turing enthusiast GPU priced at $1,200. 40 RT teraflops and 163 teraflops tensor core for AI processing. With 8 gigabytes of G6, RTX 3070 is faster than the $1,200 RTX 2080 Ti, starting at $499. Available Pascal on game performances without ray tracing. With ray tracing turned on, Pascal, using programmable shaders to compute ray triangle intersections, fell far behind Turing's RT core. And Turing with ray tracing on reached the same performance as Pascal with ray tracing off. So we doubled down on everything. Twice the shader, twice the ray tracing, and twice the tensor core, the triple double. Ampere knocks the daylights out of Pascal on ray tracing. And even with ray tracing on, crushes Pascal on frame rate. Tracing games are coming. Activision and developer Treyarch are launching a new Call of Duty on November 13th. It's a masterpiece and it looks incredible. There are dynamic lights, ray tracing, shadows and ambient occlusion, DLSS 2.0, and NVIDIA Reflex super low latency technology. Activision put together this trailer of never before seen footage. Enjoy. Were making 4K movies, rendering cinematics. Researchers built workstations for data science and AI. Bloggers built broadcast workstations. Flight and racing simulation fans built sim rigs. The 69 RT teraflops, 285 tensor teraflops, and it comes with a massive 24 gigabytes of G6X. It comes with a silencer, a 3-slot dual axle flow-through design, 10 times quieter, and keeps the GPU 30 degrees cooler than the Titan RTX design. But there's more. The 3090 is so big that for the very first time, we can play games at 60 frames per second in 8K. This is insane modern computer graphics. Developers jumped on and invented clever algorithms, like shaders that simulate realistic materials, or post-processing effects for soft shadows, ambient occlusion, and reflections. Developers push the limits of RAS giant step into the future. This is our greatest generational leap ever. The second generation NVIDIA RTX, fusing programmable shading, ray tracing, and artificial intelligence, gives us photorealistic graphics in 3070, 3080, and 3090, the first three members of the Ampere generation. You're gonna feel a boost like never before.